coding round for the Python software engineer role at Parodies. I'm Arjun, and I'm looking forward to seeing how you approach problems through code. Before we dive in, I'd like to go through a few quick checks so we're aligned on expectations. Shall we begin?
Yes, please.
Great. First question. Are you comfortable working remote?
Yes, I'm comfortable working remote. I've been working remote even in my last job, so I can do that. Yes.
Got it. Thanks for confirming. One more. Are you okay working UK timings?
Um, Let me check what UK timings would be. Mm. Can you tell me what UK timings would be in IST?
Sure. UK timings typically follow GMT, and during daylight saving time, they shift to BST, British Summer Time. For GMT, you're looking at about 5 hours behind IST.
Yeah, I can
And
do
for
that. I can actually do that.
all right, noted. Thanks for confirming. So, Anand, could you briefly introduce yourself? Maybe share a bit about your background, your career journey, and what you're currently focused on.
Hey, so I'm Anand. I am currently working at Expert Hire. Um, I've been a Python software developer for the last 6 years, and I've been working with Flask, Django, Fast API, different Python frameworks, and I've not stuck to traditional development per se, not just stuck to traditional development. I've worked on both serverless architectures. I've built agentic workflows. Prior to agentic workflows, I've built ETL pipelines. I've worked with PySpark. I've worked with CV, traditional machine learning and deep learning algorithms. Um, I've also worked with, like, talking about development with an array of databases, both SQL and NoSQL, Dynamo, Mongo, PostgreSQL, MariaDB, MySQL, all of it actually.
Got it, Heyman. You've covered a pretty solid range there. Python development, frameworks like Flask and Django, server and serverless architectures. Sounds like you've had both breadth and depth in your journey so far. SQL and NoSQL databases, ETL pipelines, even machine deep learning. Quite impressive. All right, now, let me ask you something to start. Based on your work with consistent architectures, could you walk me through a specific project where you designed or contributed significantly to a backend system? Maybe
Yeah,
something
so
more.
when I was working at Techion, I led their L&D department, um, L&D, and uh, what we sold was a very complicated product called ARC. It is an ERP solution, very extensive. It's called a dealer management system, where there are different modules. There are about 72 modules, including retail, sales, repair orders. There's honestly a lot of different modules, right? Could be parts, could be a lot of inventory stuff, could be HR related. And the implementation time for a dealership to actually start using ARC over whatever they were using before, it could be R&R, Dealer Track, any other software that they used to. It used to take about 8 months in training and a lot of migration, a lot of process, which is very time consuming for both the dealership and us. So we made a self-serve learning platform where we could mock create these scenarios and have them work on a sandbox environment, which is very similar but not exactly identical. So the entire architecture over there was serverless. Everything was on Lambdas. We'd actually used AWS Chalice. I architected the entire solution end to end. Chalice because it's an extended framework of Flask, which just makes it easier to deploy on a Lambda. We were using DynamoDB initially, but we did have uses from like a lot more usage than we expected, so we had to make it server ready, and we migrated from Dynamo because we had RCU throttling issues. We migrated from Dynamo to Mongo because of the scale. We also had an ES layer for quick searches and analytics, specifically because we were just using ES analytical DB layer. That's one of the projects that I worked on extensively end to end and actually led the entire development for that over a period of 2.5 years.
That's a lot to unpack. Very cool project. So, You built a self-serve learning platform using a serverless architecture with AWS Chalice and Lambdas to support training and migrations for dealerships trying to adopt Arc. Plus, handling the scalability with DynamoDB, MongoDB, and integrating Elasticsearch for analytics and quick searches. Impressive how you managed those migration challenges, especially moving out of RCU, throttling with Dynamo. All right, since Flask, via Chalice, played such a crucial role there, let me ask, how did you handle request validation in your implementation? More specifically, any libraries or patterns you leverage to ensure robustness in validating API requests?
So, what I traditionally like to do is I like to use a blueprint architecture where, let's say, I have my dashboard and the dashboard APIs, I'll put it through a blueprint specifically because all of my dashboard APIs, I could add a before request decorator and add a middleware, right? And over there, I could use a combination of JWT to validate the user request and only signed requests get through. I could add rate limits, which is very specific to certain type of batch processes. So I am aware of both before request, after request, like all the different decorators that are available in Flask, and structuring it out as a blueprint makes it easier for me to assign um, different middlewares essentially um, in an application.
Ah, got it. Makes sense. The use of Flask Blueprint for modularity, combined with before request decorators for middleware handling. Very nice approach for isolating concerns like JWT validation and rate limiting batch heavy APIs. That modularity must make it easier to scale specific parts, too. By the way, speaking of rate limiting in batch processes, curious, how do you typically determine or even enforce optimized rate limits for sensitive APIs? Do tools like Flask extensions come into play for you? Or do you prefer building custom solutions?
So mostly Flask extensions do work, right? And most of my rate limits are on the LV level or on like the DevOps level. It's not even on the code level. On code, I'm prepared to handle as much as I can, especially with multiprocessing, concurrency, any possible technique to, at least in terms of batch processing. But the number of times that actually gets called, exponential rate limiting, all of those, I just usually put it on the DevOps ALB level.
Ah, I see. Handling rate limits at the ALB or DevOps level definitely keeps things efficient while avoiding bottlenecks in your code logic, especially since you're designing the backend to handle high loads via multi-processing and concurrency. Totally makes sense for batch-heavy systems. Okay, pivoting slightly. Since you've worked a lot with AWS resources like DynamoDB and Lambdas, how would you tackle a scenario where frequent conditional writes in DynamoDB begin to create write conflicts or excessive retries?
So that is a very common problem where the DB does get locked because of a lot of retries, and especially the Boto 3 client as an ORM even creates 50 idle connections every time you connect to a DynamoDB, and if you have multiple servers, especially on a cube cluster, it's going to create more idle connections, and that there will be these problems. What I typically do is I'd handle it using mutex and deadlocks, create a situation where there is no double writing that's happening, pass it through a queue all the time. It could be as simple as just an SQS layer in the middle, and writes get duplicated if there's a duplicate write, and then only then these keep executing in batch if it's not a real time scenario. If it's a real time scenario, I'm going to make sure that there's only one client actually doing the updates.
Ah, interesting. Yeah, implementing a mutex mechanism or introducing an SQS deduplication layer in between definitely helps keep writes orderly and avoids the chaos caused by frequent retries. That sounds like a scalable approach, especially with batch processing for non-real-time scenarios. And it's smart to limit active clients for real-time updates. Reduces contention significantly. Cool. Let's transition a bit. You mentioned PostgreSQL in your skill set. How comfortable are you with writing complex queries, such as paginating large result sets efficiently while handling concurrent inserts and deletes? Can you describe your approach for achieving that?
I think I can do that pretty easily. So with PostgreSQL, I usually typically use the PsychoPG2 library in Python, and for actual like pagination, I just use offset and limit. That's just my strategy to pull data um, and make paginated queries. So like my query is going to be select whatever from whatever table, and there's going to be a condition where whatever, if we require that in terms of filters, um, we could order it or not with a certain limit and offset, just limit rather.
Okay, yeah, that's definitely a common approach. Using limit and offset for pagination in PostgreSQL queries works straightforwardly for many scenarios. But how would you tackle situations where concurrent inserts or deletes disrupt the consistency of paginated result sets? Say the offset position no longer lines up due to those operations. How would you adjust your strategy for that use case?
Um, if the offset position doesn't actively line up, then that is a problem. Then maybe we don't do that, and maybe I use something like a next last seen ID. Based on the last seen ID, we order it. We order all the queries, and I do store the last seen ID somewhere. And depending on what the last seen ID is going to be, I can just fetch from that point onwards for my next query.
Ah, got it. Yeah, relying on something like the last seen it, especially if we're working with an auto-increment primary key, makes pagination a lot more stable in the face of concurrent inserts or deletes. You can always pull rows greater than the last seen it to maintain consistency. Did you ever have to implement something along these lines in any project? And if so, what additional measures did you take to ensure the system didn't break under high concurrency scenarios?
I don't remember implementing exactly this, but I see that page size can be a problem. Limited, like soft limits on every end, we do have multiple checks. So if it's a if it's a DB that's just constantly being written onto, right? We do want to have those checks at least in place. Other than that, I think that's it.
Right? Monitoring checks can definitely help keep things in control when dealing with dynamic DB writes. Thanks for diving into that. Makes sense. Now, let's shift gears into a major challenge. You're helping refactor a microservice built in Flask that processes batch data submissions for a client analytics system. A performance issue has been traced to how JSON payloads are validated. Can you describe how you would efficiently validate deeply nested JSON structures in Flask without blocking the event loop? Include libraries or patterns you might leverage to address this. You can open the coding editor provided. Let me know once you're ready to get started.
Yeah, so I'm
All right.
looking at the coding editor right now, and it says you're helping refactor a microservice built in Flask that processes batch data submissions for an analytical system. Performance issue has been traced to how JSON payloads are validated. Describe how you would efficiently validate a deeply nested JSON without blocking the current event loop. Right, I can do that. So what I typically use something like this is Pydantic. Right, Pydantic helps me with a lot of validation on multiple JSON nested levels. The idea with Pydantic is uh, I can essentially handle two nested levels as two different classes and assign one class to a different variable, right? So let's just say class. I define a new class called level one, right? And within level one, let's just say we have an attribute called um, A, which is a string, B, which is another um, array of. I mean, it can be a list, right? Like it's a list. C, that can be an int, and let's say I define another class called level two, which is going to be um, what B is going to be assigned to. That's another object, right? It's multiple level of nesting. So what we're looking at, and that contains X, which is another int, Y, which is another string, and Z, which is another list. What I can do is A can be of type string, and B essentially is of type level two now, right? And To validate all of this, let's say we're getting a new JSON, right? We've got it from somewhere. Let's say we just have it from somewhere. We don't know, like got it from an API, right? Actually, this is from a client analytics system. Yeah, I got it from the client, right? Then I'd create a base model. That's what we're looking at right now with level one, level two, different steps of nestings. And I just do a base model validation against new JSON, and it's going to parse the new JSON into those different levels with the key. It's going to also have it's going to have the field, it's going to have the key, right? Field, let's say it's called A. Like that's the JSON field we're talking about. And it's going to validate against the different data types that we have specified over here, right?
All right, I've got your code submission. Shall we continue?
Yeah, we can continue.
Looking at your submission, I see you've implemented a
Yeah, go on.
All right. Based on your submitted solution for validating deeply nested JSON structures in Flask without blocking the event loop, I noticed you leaned toward integrating libraries or patterns like async and schema to handle asynchronous validations. You also mentioned schema predefining for performance optimization. That's solid. It demonstrates your grasp on non-blocking designs. However, I'd like to ask how you'd handle edge cases where the JSON structure deviates significantly from the schema or unexpected data types are encountered. What's your strategy for gracefully failing in such scenarios while maintaining system performance?
We can just end the event loop. To be honest, we can just end the event loop. We can exit gracefully. We can do an asynchronous close. That way, it doesn't really affect the main program's operations. But like the stuff still goes on, but you can always just throw an error saying that hey, this got closed, and this is why the event loop got closed.
Ah, got it. Makes sense. Throwing an explicit error for clarity while maintaining the integrity of the main program operations could work well in most systems where tracing becomes crucial during such failures. It's a thoughtful way to ensure the failure doesn't ripple into higher level operations. Okay, time is tight, so let's do a quick wrap up here. What's one question you have about the role or the organization before we conclude?
So I wanted to understand what my day to day would be like and what I'd be working on specifically.
Sure thing. In this role, you'd primarily focus on developing high-quality software applications using Python. Your day-to-day will include collaborating with cross-functional teams to understand user needs, contributing to design discussions, coding and debugging applications, and implementing robust solutions on frameworks like Flask and Django. You'll also work on optimizing databases like PostgreSQL and DynamoDB, making sure they're efficient and scaling well, as well as handling integrations with AWS cloud services. There will also be constant
Do you
learning.
know what kind of AWS cloud services?
Oh, that's an interesting shift. Though I'm
No, like, do you know what kind of AWS cloud services?
got it. AWS gets pretty broad. Based on your resume, Anand, you've worked with Lambda, DynamoDB SNS, SQS, EC2, Elasticsearch, all solid picks. Do you feel confident architecting solutions with these services? Or is there any one in particular you'd want to dial into?
No, I'm confident with all of those, right? And I don't have any more questions. We can end the interview.
All right, thanks for confirming, Anand. Just to double
Yes, please.